So this is the last video, feedback mechanism. I have given you one example of thyroid gland and pituitary, the connection between pituitary gland and thyroid gland, how anterior pituitary controls the activity of thyroid and what is the functioning. Children, here what you have to see is, just hold on. What you have to see is that I have drawn a pituitary gland anterior lobe because we know very well that thyroid stimulating hormone is secreted by anterior pituitary. No work of posterior pituitary as of now, so we won't talk about posterior. What you have to see is that here the anterior lobe is releasing TSH, but TSH doesn't get released like that only. There is some interconnection. When it is needed, only then it is released, right? And it is released under the impact of hypothalamus, because hypothalamus is the main governing body. It can control pituitary activity. So hypothalamus will release the thyroid stimulating hormone releasing factor, thyroid regulating factor, and this is the license which is given to anterior pituitary so that it can release TSH. Right? This TSH generally goes to thyroid and stimulates. So stimulates thyroid, and ultimately thyroid releases thyroxine hormone. Now what you have to see is, this is a simple flowchart that TRF got released from hypothalamus. It allowed the release of TSH from anterior pituitary. Then anterior pituitary sends TSH to thyroid. Thyroid gland gets stimulated and releases thyroxine. Now two conditions could be there, children, whether you need more thyroxine or you don't need any more thyroxine. For this, what you have to do, either your body will be using thyroxine continuously, and there will be a condition where the thyroxine concentration will go down in blood, right? And this is something, this lack of concentration of thyroxine is a kind of stimulus, or is a kind of message which is taken by the chemoreceptors. These chemoreceptors, which can sense the concentration of thyroxine, they send the message to the hypothalamus that okay, the thyroxine concentration is going down, right? What should be done then? Then hypothalamus should allow anterior pituitary to release more thyroid stimulating hormone so that this thyroid gland can be stimulated and more thyroxine can be secreted. So you are actually asking to start the secretion. You are actually asking to release more thyroid. So this kind of feedback is known as positive feedback. When you are asking hypothalamus, when you are sending message to hypothalamus and pituitary complex to release a hormone, that is a positive feedback, right? And it is always given when the concentration of a hormone in a particular hormone in blood, it goes down. But there could be a condition that suppose continuous secretion of thyroxine will lead to the higher concentration of thyroxine in blood. At that time, your blood cannot get saturated with hormones. You know very well that over secretion and under secretion both are problematic. So in that case, when this over secretion kind of condition is there, at that time the chemoreceptors, they send the message to hypothalamus to stop the secretion of TSH, because till the time this TSH is secreted, the thyroid is stimulated. So ultimately what you have to do to stop all this, you have to basically cancel out TSH, and for this you send a negative feedback to hypothalamus, and hypothalamus will stop TRF. TRF is not there, so TSH is also not there, so your thyroid gland is not stimulated anymore and the thyroxine concentration is balanced. I hope this much is clear. If you have any issues regarding feedback mechanism, you just let me know and I'll be sorting it out. Thank you.